Okay, so this is where we are. What I want to do now is I want to add a dot. So let's say we want to draw the graph of a function, and I want like a dot at its beginning and a dot at its end. And to do that, we're going to use the object called dot, and here are the arguments that it takes. So again, when we construct a dot, all of these are optional. So I'm just going to do it without any of these arguments and see what we get. So I'm going to say dot is equal to dot. Again, dot is a class in Manim, and I have self.add ax, and let's see what happens if we do this. Okay, so I got both of those. I am adding ax and dot, and what happens is it puts a dot right there, default position, in the very center of the screen here. So notice how there's the scrolling going on there. I don't want that, so I'm going to make it a little bit bigger just by dragging this down. Okay. Alright, so now let's say what we want to do is I want to fix its location. Like let's say I want it to be right here where x is equal to 0.5 and y is equal to 0.25. Well, to do that, I have this thing here. Point is going to be the array here. Okay, sorry about that. So let's say I want the location. So I know I said sorry about that. Why did I say sorry about that? I paused the video for a little bit because I needed to do something. I don't know how long it's been since I've been back. I guess you can see the time. But in my mind, it's been a few minutes since I last talked. It's been no minutes since you last heard me. So that was a strange apology. Anyways, I'm now apologizing for the apology. So let's say I want to have the point at x is equal to 0.5 and y is equal to 0.25. Okay, so I'm going to come over here. I'm going to put the location. Okay, this is what it says here. Point is equal. So this is the location, and it's going to be a point. Now, one thing to keep in mind here. This is going to be the x coordinate. This is going to be the y coordinate. This is always 0. Now, I believe it's because this needs to be a point, and in Manim, a point can be in 3 dimensions. So it needs to have a third dimension there for the possibility that it could be happening in 3 dimensions. But for us, this could be 0 or any other number as we will see. Okay, so I'm going to write, I want the location, point, I want the location to be equal to x is equal to 0.5, y is equal to 0.25, and z is equal to 0. And I'm going to warn you, this is not going to do what we want it to do. Okay. So what's going on here? This is not right in the x direction, and it's not right in the y direction either. So what's happening here? Okay, these points right here, those points right there do not represent the points on our axis here. It represents some absolute grid that's laid out here. So for example, if I put x is equal to 7 and y is equal to 3.5, this is going to be close to the upper right hand corner when I run it. Okay, so there's like an absolute coordinate system drawn over this window here, and if I just put a point, that's what this, if I just put a point like this, that's what it's corresponding to. Okay, clearly that would get incredibly annoying to have to deal with, because I want there to be a plot, I want there to be a point at 0.5, 0.25. I'm going to be working in the coordinate system of these axes here, not in the coordinate system that's kind of this sort of absolute coordinate system that's over the window. Luckily, the axis function, the axis class, has a method called C2P. So if we look this up, so if I go here, I can come down to the list of methods, coordinates to point. What this says, it accepts coordinates from the axes. In other words, coordinates relative to the axes, like the 0.25, 0.5, 0.25, and it returns a point with respect to the scene. So it accepts coordinates from the axes and returns a coordinate with respect to the scene. And the coordinates with respect to the scene is this sort of absolute coordinate system that's overlaid over the image here, over the window here, without regards to the axis that we have there. So I'm going to do a couple of things here. I'm going to do AX, and it's actually, you can just use, there's a shortcut, C2P. So I'm going to put the point that I want there to be. Okay, the point that I want there to be is going to be x is equal to 0.5 and y is equal to 0.25, and hopefully when I run this, if I have the syntax right, it's going to show a point right there. Okay, and that's exactly what we have there. Okay, so I want to say a little bit more about this. So notice the C2P function. If I go back here, the C2P function, it takes in coordinates. It takes in the x and y coordinates and then spits out the right thing that we need. Okay, so we don't have to do the x, y, and z thing if we do it like this. But I do want to print AX Okay, so I'm going to run this, and this Manim isn't going to do anything with this. The Python program is just going to print out the coordinates here, or the point here. So if I run it, we get 1.5, 0.75, 0. So in other words, this has the same, doing that has the same effect as doing dot equals dot, and then 1.5, 0.75, 0.75, 0. And when I run it, get the same thing there. Okay, so just so you don't think I'm doing anything tricky, completely comment that out, and we get the same thing there. Okay, but the point is, we really want to use this this right here. And now this lets us reference points relative to this lets us reference points relative to the axis, which is really what we want to be doing. Okay, so there's a lesson showing you that there is basically two coordinate systems that we have to deal with. One is the absolute coordinate system that's drawn over the window, the scene coordinates, and one is the coordinates relative to the axes here. We want to use the coordinates relative to the axes. Manim has to use the coordinates relative to the scene. So there's this translation function that translates from what we want to what Manim needs. Okay, and so that's it for this video. What I'm going to do in the next video, I'm basically going to do two things in the next video. I want to draw like one cycle of the sine function. So I want to go from minus pi to pi. So I'm going to change these axes a little bit and then show you how to actually graph a function here. And also, we haven't done any animations yet. So I'm going to show you how to graph a function and then also show you how to add these things in a sort of animated way.